Hello Math 3B. Here is a review for exam 3, and the first function we have is a parametric function, x equals t squared plus 4. The y is t cubed, and that is for t between -2 to 2. As you can see, I already imported a picture of it, but just to show you where I got that real quick, take a look at the graphing calculator, make sure it's in parametric form. There's my x part and the y part. And then for the window, since it said t goes from -2 to 2 in the directions, I use that. Since x has t squared, it's not going to have any negatives. And then x, I'm going to go with 0 to 10, and y is from -10 to 10. And then you could see the graph. So part of the reason I want to look at the graph is because right here at that cusp, that's when t equals 0. And if you go up here, this is when t equals 2. So what I'm going to do is, because the graph is symmetric, integrate from 0 to 2, so find the length of this part, and then just double the answer. Just in case, like this gave me a positive answer, and then this part down here gave me a negative answer, and at the end, I get the answer 0, and then I'd be frustrated and have to start the video all over. So I'm just going to integrate from 0 to 2, and then double the answer. So going back to the notes, also before I use calculus, I'm going to just estimate the answer by looking at this picture and seeing that, well, this part right here was when y was equal to an 8. Okay. I couldn't put a blue dot on that 8, but anyway, that blue dot is when y equals 8. And then on the x-axis, this is a length of 4. This is a length of 8, obviously not drawn to scale. And then we could estimate this length just using the Pythagorean theorem. So that's going to be c squared equals, okay, that picture was bugging me, so I'm just going to delete it. So that would be that c squared equals 4 squared plus 8 squared. So as an estimate, c is the square root of a 16 plus a 64. So that is square root of 80. So let's see, what is square root of 80? Square root of 80 is about an 8.9. So my estimate is that it's about an 8.944 for the top half, and then I would have to multiply by 2, which is, well, that's about 9 times 2, so that's about 18. Now let's do the calculus. Okay, so like I said, I'm going to integrate, but I want that to be in black. I'm going to integrate from 0 to 2, and then double the answer. And then for the arc length, it's going to be the square root. You take the derivative of x, so that's going to be 2x, and that gets squared. You take the derivative of the y, that's going to be 3t squared, and then that gets squared. And then integrate with respect to t. So that is, inside of the square root, a 4t squared plus 9t to the 4th. And with this, I could factor out a t squared. And when you factor out t squared, it's going to leave a 4 plus 9t squared. And then this t squared, you could go ahead and take the square root of it. So that's going to put a single t on the outside. And then leave 4 plus 9t squared. And this we can integrate by using u substitution. Good old-fashioned u substitution. Haven't used that for a little while. So let u equal the inside part. The derivative of that is 18t dt. And this problem does have t and dt, so keep those, but multiply both sides by 1/18. And then it's ready for the u substitution. So the 1/18 I'm going to factor out. There was already a 2 that was factored out, so now there's a 2/18 on the outside. And then integrate. And after that, it's just the square root of u and then the du. And I already factored out the 1/18, so I'm ready to go. So of course this means we're integrating u to the 1/2, so that becomes u to the 3/2. That becomes u to the 3/2, and then divide by 3/2, which means multiply by its reciprocal 2/3. And don't forget that the limits are 0 to 2. So once I replace the u, let's see, I guess I could reduce. A 2 will divide into an 18 9 times. So that fraction then becomes 2 over 27. And then replace the u with 4 plus 9t squared. 4 plus 9t squared raised to the 3/2, and then evaluate from 0 to 2. So that's 2/27. And then when you substitute the 2 in for t, that's going to be 4 times 9 is 36 plus 40. Excuse me. 4 times 9 is 36 plus 4 is 40. And then that's raised to the 3/2 power. And then when you substitute a t is 0, then the 9t squared term is going to be gone. It's just going to leave a 4. So minus 4 raised to the 3/2. And then what does this equal? So we've got sorry, I just need to write that down real quick before going over to the calculator. So we've got 2/27, and then 40 is raised to the 3/2. And then minus 4 is raised to the 3/2. And if you remember my first answer, which was an estimate, that was half of it. And so that's approximately a 9. If you double it, it's 18. And the actual answer I got is 18.147. So I feel pretty confident with that answer, 18.147. Okay, next up, with the same question or the same function, find the equation of the tangent line. So part B, and just as a reminder, x equals t squared plus 4, and y equals t cubed. And then find the equation of the tangent line. When t equals 1. So in order to find the equation of a line, you need the slope, which is dy over dx. And that just means take the derivative of y, take the derivative of x, and then substitute the 1. I guess I could reduce it a little bit. That's just going to be a 3t on the top, a 2 on the bottom, and then when you substitute 1, that means that the slope is equal to 3 over 2. The other thing we need is a point, so that means that I need to go back over here and plug in t equals 1. So the slope is 3 over 2 at the point. On the first one, if you plug in a 1, 1 squared plus 4 is a 5, and then 1 cubed is a 1. And then just do the old point slope formula. So y minus the y value equals 3/2, and then x minus the x value. And what's that going to equal? So y minus 1 equals 3/2 x minus 3 times 5, that's going to be 15 halves. And then just add 1 to both sides. So y equals 3 halves x and minus 13 halves. And since the question was in parametric form, I'm going to put the answer in parametric form. To change a line from rectangular form to parametric form is very easy. You just say let x equal t, and then you substitute that into what y equals. So it becomes 3 halves x, but now x gets replaced with t, and then minus 13 halves. So there it is in parametric form. And if you want to check it, hold on for just a moment, and I can go back to the graph and say leave that graph there, and now graph the function t, x equals t, and y equals 3 divided by 2 t minus 13 halves. And then when you graph, oh, you see the little blue line? It didn't go far enough. That's because I only have the t ranging from -2 to 2. So maybe I should have this go to, I'm not quite sure, so I'm just going to guess 20. That should do it. Yes, that does it. And then if you plug in t equals 1, then you could see that that blue line definitely looks like the tangent line. All right, so that's good news. And then on to number 2. So I'm just going to make one long video rather than like the podcast where it's just one problem at a time. Of course, you could just put it on pause and go get a snack if you like. So for example number 2, r is a polar function, 1 plus cosine of theta. And then find the arc length. So 1 arc length in parametric, 1 arc length in polar. Well, the first thing I need to do is graph this. So go over to the graphing calculator, and I need to not do that. I need to change the mode, change it to polar form, and then that I don't need anymore. And this one is 1 plus cosine of theta. And I have no idea what the window is set up. Actually, the first part is correct. That's 0 to 2 pi. And then 1 plus cosine, that could get as big as 2. So I'm going to go -2 to 2 and -2 to 2. And then it looks like a cardioid or a heart. And on the last one, I said let's break it up into an integral from just 0 to 2 and then double the answer. I could do that here, but I think I'm just going to risk it for the biscuit and go 0 to 2 pi. Another thing I should check is if you put 0, where does it start? So it starts here. And then if you go around, then like right there, that should be pi. So calculate 3.49, I believe that's pi. So if you use pi, yep, that's that point. So basically from here to here would be 0 to pi. So you could integrate from 0 to pi and then double the answer. Just to challenge myself, I'm going to go 0 to 2 pi. If the answer ends up to be 0 at the end, I'm going to be disappointed and go back and say use 0 to pi and then double the answer. And actually, if that happens, it's not that big a deal because you've done most of the work. You just change the very last limit. So it's not going to be that big of a deal one way or the other. All right, so find the arc length. So we're using 0 to 2 pi. And then for arc length, when it's polar, we need the derivative, and the derivative of cosine will be negative sine. And we need to square each one of those. So take the r squared plus the r prime squared. And then those are going to go inside of a square root, and then that's what we're going to integrate. But I think I'm just going to work out some of the math first. So r being squared means 1 plus cosine theta being squared. And then r prime also gets to be squared. So when you square this 1 plus cosine, the first term would be 1. The middle term would be 2 cosine of theta. And then when you square cosine, that's going to be cosine squared. Oh, good news, because look at what happens next. It's going to say plus sine squared. And then we could use the good old sine squared plus cosine squared equals 1. Combine it with this first one, and we've got 2 plus 2 cosine theta. All right, so that's what goes inside of the square root. So arc length is going to be integrate from 0 to 2 pi. And then inside of the square root goes 2. Oh, you know what? They both have a 2. I think I'll factor that out. So if you factor out the 2, it's going to be 1 plus cosine. And then you just sit quietly and sorry, I thought I lost a negative sign, but the negative got squared, so negative squared is a positive. Okay, and so you look at this and you say, well, okay, I'll try u substitution, but the thing is that won't work because when you do that, the derivative is going to be a negative sign, and that means outside of the radical, you would need a sign right there with the d theta. So that doesn't work. And then you think, is there any other trig identity that has 1 plus cosine? So there is, oh, wait a second, I know. How about the identity that says, and I'm going to put the identity in blue. How about the identity that says cosine squared theta equals 1 plus cosine of 2 theta over 2. And we usually use this identity going this way, that you have a cosine squared you're trying to integrate and you have trouble with it, so you use this identity going from the left to the right. But we are going to go the other way around. So this one has the 1 plus cosine, which is good news. Just multiply both sides by 2. So 2 cosine squared equals a 1 plus cosine of 2 theta. And then this is almost exactly what we need for this. The only thing is our identity has 2 theta. So if you replace this just with a theta, that means you have to cut this in half. That means you'll have to also cut this in half. So you can use the identity that 1 plus cosine of theta can be replaced with that one. Then back to the black pen. So we're integrating from 0 to 2 pi. Inside of the square root, it already had a 2. And then I'm replacing what's in the parentheses with a 2 cosine squared. And then the theta has to be replaced with theta over 2. And then that's double good news because this means we've got a 4, and you could take square root of that. And this is a cosine squared, so if you take the square root of that, it's just a cosine. And then finding the integral of cosine is easy enough. So the 2 can stay on the outside. The antiderivative of cosine will be sine of theta over 2. And then there's the chain rule, which says take the derivative of the inside, which is going to be a half, and then divide by a half. And that gets evaluated from 0 to 2 pi. And uh-oh. Guys, you know what happened? Exactly what I thought I could avoid. I thought I could use 0 to 2 pi and just double the answer. Oh, excuse me. I thought I could use 0 to 2 pi and not have to double the answer. But if you use 2 pi in here, that's going to say sine of 0, or sine of pi, which is 0. And when you use the 0, it's going to say sine of 0, which is 0. So it looks like I do need to adjust and say, all right, integrate from 0 to pi. And if you do that, you then need to double your answer. And now it's going to work. All right, so this is a 4. When you divide by this 1/2, that means that you invert and multiply, which means there's going to be 2 times 2 times 2, also known as 8. And then it's going to be sine of pi over 2 minus sine of 0. And then the sine of pi over 2 is a 1. The sine of 0 is 0. So that means that it's going to be 8 times 1. So the answer is 8. All right, then on to number 3. Et toi? So find the sum. So chapter 11. So what if it looks like the sum as n goes from 1 to infinity, and then on the top of the fraction it has 2 to the n plus 3, and then on the bottom it has 3 to the 2n plus 2. So just by looking at this one, it looks like it's geometric. And the thing with the geometric is it needs to start at 0, and then it has a, and then r is raised to the n, and then the sum will be a over 1 minus r. So once you have it set up in the geometric series form, finding the answer is very easy. So one thing is, it has to start at 0. So that means from this, I need to subtract 1. And if you subtract 1, then you'll need to add 1 here to compensate for it. So let me just show you in numbers real quick. If this is n equals 1, and you substitute a 1 here, that means that this is going to be 2 to the 4th for the first term. If we then want this to be a 0, and this becomes a 0, and we still need it to say to the 4th, that means we're going to have to add 1 to this. So if you're going to subtract 1 here, you need to add 1 here. So I now am going to have it start at n equals 0. And then the top is going to be 2, and then add 1, so it's plus 4. And then on the bottom, you have to be careful because it has 2n plus 2. So if I were to use n equals a 1 here, that means the very first term would have 3 to the 4, 2 plus 2. But if I want to start with a 0 and put a 0 right here, then adding 1 right here is not good enough. So because of this 2n, we actually have to add 2 instead of 1. So on the bottom, we actually have to add 2. So it's going to be 2n plus 4. Okay, now I need it to just have 2 to the n and something to the n on the bottom. So for the one on the top, you can factor this as 2 to the 4th times 2 to the n. On the bottom, you could factor it as 3 to the 4th times, and then I'm just going to take this part and call that a 9. And then 9 to the n. So that means that we've set it up in geometric form. I'm just going to, make a sloppy sigma? No, I'm just going to say, well, 2 to the 4th means 2, 2, 2, 2, so that's 4 times 4 is 16. And 3 to the 4th is 3, 3, 3, 3, which is a 9 times a 9, which is an 81. And then the 2 and the 9 both have an exponent of n, so I can use that. And because this is the r, which is less than 1, therefore it converges. Not only does it converge, but the answer is going to be, so put the r, 16 over 81, and then on the bottom goes 1 minus, sorry, I just called it r. Put the a on top, 16 over 81, and then on the bottom, 1 minus 2/9. So that is going to be 16 over 81, and then on the bottom there is 9/9 minus 7/9, so this is minus 2/9 is 7/9. So on the bottom is 7/9, but if you invert that, it becomes 9/7. And I could reduce a little bit, like a 9 will divide into an 81 9 times, but it leaves me 16 over 63. And then I want to check that answer by using the calculator. And I just got the answer 16 over 63, right? 16 over 63. I got 16 over 63. And then to check that answer, I can do the sum sequence. So go to the list, do the math, do the sum. Next, do the list, operations, the sequence. And then with this one, I have to type it in myself. And I'm going to type in the very original problem, 2 raised to the n plus 3. Right now it's going to put theta, but it doesn't really matter as long as you're consistent and keep using theta. Or as long as I'm consistent and keep using theta. Then divided by 3 raised to the 2 variable plus 2. If I can type a 2, there we go. And then we're using the variable theta. And then in the directions it said start with a 1, the very first problem. And let's say you add up 50 terms. The calculator should be able to handle 50 terms. And it does, and it got the exact same thing, 0.254. All right, so that's good. And then uno más. So with this review, I'm not going to do the vectors because they're pretty straightforward. Just make sure that you do that problem set with the vectors before the test. So one more is a series. This one starts at 0, so we don't have to do that adjusting part. And then it's got 3 to the n plus 1 over an x to the 3n. And then find the values of x so that the series converges. So this one is a geometric series. It is almost set up perfectly, but not quite. It does have the starting at 0, so that's good news. I just need to do a little bit of adjusting. So this one is going from 0 to infinity. And then on the top, I would factor it as 3 times 1 and then 3 times n. And on the bottom, it's basically an x cubed that is raised to an n. Because when you raise a power to a power, you multiply those exponents. So I could rewrite the bottom like that. And then this part right there is basically the r. So this one has the sum. And then the 3, you could just put it in front and then write 3 over x cubed. And both of those were to the n. And it didn't say find what the series equals. It's just saying what are the values of x so that it converges. So in other words, this is the r. And if r in absolute value is less than 1, then it converges. So if you take the absolute value of 3 over x cubed and say that has to be less than 1, That's what's going to make it converge. So now I just need to do algebra to solve for x. So one way to do it is you could invert the fraction and make it x cubed over 3. That gets the x to the top. But then you also have to invert the inequality. And then when you want to take off the absolute value, you would have to say the x cubed over 3. Perhaps it's a positive number, in which case you didn't even need the inequality. So you say that is still bigger than 1. And if it was a negative, then you would have another case and say, well, if this was negative, then you would have to multiply by a -1. And when you multiply by a -1, it's going to switch the inequality and it's going to give you a -1. And then put an or in between and just do algebra on each side. So this one is going to become x cubed is less than a -3. Or in other words, x is less than the cube root of -3. And because it's a cube root, that is not an imaginary number. And then the algebra would be the same over here. So x cubed is bigger than a 3. And then take the cube root. And there is the answer.